Today we are going to be completing our Intermolecular Forces Lab. So up first, we are going to be judging droplet shape. So we have water over here. We're going to take a pipette full of, and we are going to put one drop on our slide. Then we are going to go over to our isopropyl alcohol. And we are also going to put one drop on our slide. Now you can see the difference already. Our water droplets stayed nice and together, while our alcohol droplets spread out. We have one more. We also have our glycerin droplet, and we put one droplet of glycerin on there. And we can see that the glycerin droplet stands up even more. To compare a side view, we can't see our isopropyl alcohol basically at all. Our glycerin droplet on the right side is still standing up, and the water has spread out slightly while still standing up. For part 2 of the lab, we are going to be visualizing how strong the hydrogen bonds are by checking the tension. If a chemical ruptures the surface tension of a fluid, the skin of the liquid is going to recoil away. The bigger the recoil, that tells us more about the forces. So I have 3 Petri dishes. I have one with water, one with alcohol, and one with glycerin. And I am going to speckle some flakes on top of each of them. All right, so now each of our substances has some flakes floating on top of it so we can judge the surface tension. Now we're going to break that surface tension with some of our dish soap. So starting off with the water, we are going to place a drop of dish soap in there and watch what happens. Okay, so we saw everything move to the outside. Think about the speed that it moved at. Now we're going to go over to our alcohol. And we can see that nothing moved because the surface tension was already broken. Our flakes already sunk down to the bottom. So when we add soap to them, they don't move because our surface tension is so low, it's already been broken. And last but not least, we have our glycerin, where when we add soap to that one, we can see that things move out of the way, but they move a lot slower than we saw move with the water. Last but not least, we are going to be determining the impenetrability of these different substances. So liquids with strong intermolecular bonding will be less penetrable than those with weaker intermolecular bonding. We are going to do that by using paper clips. The easier it is to float a paper clip on the liquid, or how quickly the paper clip falls through that liquid if we can't get it to float, is going to help us determine how impenetrable it is. So up first we have our water. And we're going to really carefully try and get that paper clip to go in there. And we see that it won't and that it sinks. When we move over to our alcohol, we're going to try the same thing. And it sinks even faster than the water did. And last up, we are going to do our glycerin. We're going to try and float that one in there. And we can see that the paper clip is actually able to float on top of the glycerin and does not sink at all. All right, using the data that we have gathered in these 3 lab activities, answer your questions.